Lesson 3, polynomial functions. So a polynomial function is some sort of function that has x's and y's and different numbers. And the ones that we are familiar with are linear functions, quadratic functions, and cubic functions. We also have constant functions, which are just straight lines that are horizontal. So for the first, we wanted to determine if the following are constant, linear, quadratic, or cubic. So the first one is linear. It's a line, it's going up by a constant amount. The second one is quadratic. And the third one is a cubic function. So note, a cubic function has 2 bumps. Okay, so for the following examples, we want to determine if they're linear, the degree, and the shape. And we also want to find the leading coefficient. So when you have a parabola, a line, or a cubic function, the degree is always the highest exponent in the equation. So whichever x has the highest exponent, that is the degree of your equation. So for the first one, our highest x value is 2 to the power of x, so the degree is 1. For the second one, 2x squared is our highest value, so our degree is 2. The exponent is 2. For the third one, our highest degree is 4x to the power of 3. It doesn't have to be in order. So the degree for this one, because this is to the power of 3, is 3. Now the degree determines the shape of the function. When the degree is 1, it's linear. When the degree is 2, it's a parabola or quadratic. So that would be the shape. And when the degree is 3, it is a cubic function. The last thing that's really important is our leading coefficient. And our leading coefficient is always the number that's in front of our highest degree. So this number is in front of our highest degree, so our leading coefficient is 2. 2 is in front of our x squared, so our leading coefficient is also 2 for this one. For this one, negative 4 is in front of our x to the power of 3, so our leading coefficient is negative 4. For the bottom ones, these ones are a little bit different because they're not in standard form. So the way that we would do these is we'd first get rid of the brackets. So for this one, we'd expand, so this would be 0.5x minus 1. So our degree, this is still our biggest x term, so our degree is 1. The shape is a line, and the leading coefficient is 0.5. For this one, we have to get rid of our brackets first. So this is x squared minus 3x minus 2x plus 6. And this whole thing is multiplied by 2. So this is the same as 2x squared. Negative 3 minus 2 is minus 5. Times 2 is minus 10x. And 6 times 2 is 12. So our degree, this is our highest value of x, is 2. The shape is a parabola or a quadratic. And the leading coefficient is 2. For the last one, we want to get rid of our brackets. So we expand. This is x squared plus 1x minus 2x minus 2. The whole thing is multiplied by 3x. So now we multiply this in, so we get 3x cubed times 1x minus 2x is minus 1x times 3x is minus 3x minus 6x. So our highest degree is 3, so our shape is cubic, and the leading coefficient is our number in front of x to the power of 3, so it is 3. The coordinate plane is what we call our x and our y axis. So if this is x and this is y, we call each section of the coordinate plane a quadrant. So this is the same as quadrant 1, and we use Roman numerals. So I. If you need to put a 1 to remind yourself, put a 1. This is quadrant 2, and this is quadrant 3, and this is quadrant 4. And we use Roman numerals because it's easier to explain which quadrant it is in without having to use a number. So Roman numerals is just kind of like using a variable almost. It's a little bit easier to distinguish between numbers and the quadrants. So you have to be familiar with which quadrant is which. Okay, determining end behavior. The end behavior is how it acts at the ends of each part of the line. So if we were doing a constant, there's two ways we can have it. We can have it if it's a positive number, so it would look like this, and also if it was a negative number, it would look down here. Now our end behavior over here, for our first one, it starts in quadrant 2, and it goes to quadrant 1. So the end behavior is from quadrant 2 to quadrant 1. You can put a line or you can write 2. For our negative constant function, it goes from quadrant 3 to quadrant 4. So those are the end behaviors for a constant function. You can do the same for linear functions. So if a linear function is positive, it should look something like this. And if it is negative, it could look something like this. And our end behavior for a positive linear function would be it would start down here in quadrant 3, and it goes up to quadrant 1. So from quadrant 3 to quadrant 1. For negative, it starts in quadrant 2, and it goes to quadrant 4. So those are the only two ways you can draw lines. There's no other way you could draw your line like that. Eventually, it would still get down here. So that is how a linear line looks. If a quadratic is positive, it will open up, and if it's negative, it will open down. So the end behaviors for a positive quadratic is it starts in quadrant 2, and it ends in quadrant 1. A negative starts in quadrant 3, and it goes to quadrant 4. And lastly, for a cubic function, if it's positive, it's going to look something like this, and if it's negative, it'll look like this. So a positive cubic function starts in quadrant 3, and it ends in quadrant 1, and it's the same as a line. And a negative starts in quadrant 2, and it goes to quadrant 4. So that is the end behavior for all polynomial functions up to the third degree. Now we are going to talk about turning points. So a turning point is when a graph changes direction. So for constant functions, there's none. It doesn't change at all. It's always going the same direction. And same with a line. It doesn't change at all. So there's no turning points for a constant or a line. A parabola, regardless of if it goes up or if it goes down, it's going to start going down, and then at the vertex it flips, and then it starts going up. So right here is a turning point. So a quadratic has one turning point. Now for a cubic function, there's two options. First, if you have a function that goes up, turns down, and then comes back up again, it starts going up, then it comes down, then it goes up again. So you have a turning point here and a turning point here. So a cubic could have two turning points. But it could also have one other situation, and it would look like this, or like this. So for this one, it's going down, and then it's still going down. This one, it's going up, and it's still going up. So cubics can also have 0 turning points. Okay, for the following graphs, we want to determine the degree, shape, intercepts, end behavior, turning points, domain, and range. So for the first one, we can tell our shape is it's a line, which means that the degree is 1. We know that there is one x-intercept, and it's right here at x equals 0. We know there's one y-intercept, and just so you know, there's only ever going to be one y-intercept. And it's also right here at y equals 0. The end behavior, it starts up here in quadrant 2, and it goes to quadrant 4. Down here, there's no turning points. The domain for a line is always x such that x is an element of the real numbers. And the range for a line, because it can go up and down forever, is y such that y is an element of the real numbers. It can go on in infinity, left and right, and up and down. So there's all the information for our first one. For our second one, the shape is a parabola, or a quadratic if you want to call it that. So that means our degree is 2. There are 1 x-intercepts, and it's right here at x equals 1. The y-intercept, it crosses right here, at y equals 1. The end behavior, it starts in quadrant 2, and it goes to quadrant 1. There's one turning point. Our domain, because it goes on in each direction, is x such that x is an element of the real number set. And our range, because it has a minimum, we want our numbers to get bigger than the y point in our vertex. So we want y to be such that it's greater than or equal to 0 for the real numbers. So there's all the information for the quadratic. For the last one, we see that the shape is cubic, which means that the degree is 3. There are 2 x-intercepts, one at x equals 0 and another one at x equals 2. The y-intercept, where it crosses the y-axis, is at y equals 0, right here. There are 2 turning points, and I skipped end behavior. So end behavior, we start here in quadrant 3, and we go to quadrant 1. There's one turning point, and like a line, domain is always x such that x is an element of the real number set, because it goes left and right forever, and because it goes up and down forever, the range is also y is an element of the real number set. So there is all the information for a cubic, parabolic, and linear function.